This is page 5 of quadratics. We're going to do intersections now, and I don't remember if everybody has done this already, but when we found the intersections of lines, one of the ways we found intersections of lines was using second calc 5, option 5 intersect. When we did that, we could find the intersection of lines. The great thing about this function is you can find the intersection between any two functions, and they can be curves. Okay, so you'll find that as we do math studies, the calculator is going to become easier and easier because we're going to dominate all the useful functions in a matter of a couple months, and then after that, you're going to be using the same functions on the same calculator functions on more and more difficult math functions. Okay, so let's see. We've already done intersections of lines. Okay, we found the point where two lines intersect. Now what we're going to do is find the point where maybe a parabola and a line intersects. And as you can see, maybe it intersects in two places, right? Maybe it intersects in no places, and maybe it'll intersect in exactly one place, right? So there's three possibilities. When you have a line and a parabola coming together, you might miss totally, you might hit in one spot, and you might hit in two spots. So let's see for this first problem here. So here's two functions, x squared plus 3x minus 5 and x minus 2 for the domain -5 and 2. And we don't know what that means yet. Why is that important? But let's go ahead and do what we do in math studies when they give us a function. When they give us a function, of course, the first thing we're going to do is we're going to put it into y equals. So into y equals, I'm going to put each function. I'm going to put the parabola and I'm going to put the line. So the parabola is x squared plus 3x minus 5. And the other function is x minus 2. And I'm going to graph these. And I'm going to get a parabola. And I'm going to get a line which crosses it in two places, right? And so now what I'm going to do is I'm going to use the function second calc intersect to find this point and this point. So remember how I said that when we do second calc intersect, it always asks you for a guess. And I said, well, in this case, the lines only intersect in one place, so the guess is anything. Okay, in this case, we have two intersection points, so we need to be careful about what our guess is in order to get the point that we want. So first we're going to do intersect, and then we're going to say, okay, is the first curve the parabola? Yes, it is. Is the second curve the line? Yes, it is. What is your guess? Okay, now it's important. We're going to go left and right with the arrows to show where our guess is. If we want the left point first, we're going to put the cursor close to the left point. It doesn't have to be exactly there. It just has to be closer to the left point than it is to the right point. And we'll hit enter, and it finds the intersection exactly at -3, -5. So one of our intersection points is -3, -5. And then there's another intersection point right here, right? So we'll find that one. We have to do everything all over again. Second calc, we could do 5 or go down to intersect. First curve, yes. Second curve, yes. If you only have two functions, y1 and y2, in the calculator, then, of course, the calculator asks you exactly the two functions that you want. If you have 3 or 4 functions, like we did in the investigation for the bowling alley, maybe you need to say exactly which functions you want to intersect. So I put the cursor close to this intersection point, I hit enter, and it gives me an intersection of 1, -1. Okay, 1, -1. So we have 2 points which are intersections between these two functions. Now we're going to go back and look at the domain. They say the domain between -5 and 2. What does that mean exactly? Well, one cool thing about the calculator is it's got this window function where you can restrict the domain. So what if we just use the calculator window function to see exactly what the domain of -5 to 2 looks like? So I'm going to do that. So do you see what I did there? I changed the x min to -5 and the x max to 2, and now I'm going to graph it again. And now it's going to only show me the domain -5 and 2. Ah, interesting. Okay, and so now we can see that the two places that cross, the two places that have intersections, are indeed within the domain -5 and 2. So both of these intersection points are valid for the answer to this question. Oh, now we're going to do it with algebra. So those of you who love doing algebra for vestibular because you think it's awesome, let's do part B. If you are not in that group, then you could watch or skip this. It doesn't matter. Sometimes it's good to kind of know how to do this for SAT or whatever. Write down f of x equals g of x and solve it for x. Do you get the same answer as you did for part A? Okay, so even if you're terrible at algebra, the first step is not that bad, is it? F of x equals g of x. This is the way that you can solve for common points between two functions. So our functions are x squared plus 3x minus 5, which is the f function, and the g function is x minus 2. So we're going to write each of those, one on the left and one on the right side of the equal sign. Of course, it doesn't matter the order because 3 equals 3, you know, it's like it doesn't matter which comes first. Now we're going to solve for x. How do we solve for x? Remember, and this is the part that you're in math studies because you wanted the option to not do algebra, right? So the way you would solve this with algebra is you would do the same thing to each side and isolate x's, but you're like, whoa, I got x squared, I got x. How do I get these to one solution? I mean, I'm going to have like an x squared term, I have an x term. Even Math SL people forget this and freak out on the exam. Basically, whenever you have a quadratic, your objective is to express this with everything on the left side and then 0 on the right side, okay? So like a whole bunch of stuff on the left side and 0 on the right side. If you do that, you can figure out two factors that when they multiply together, they're going to be 0. When you have two factors that multiply together to get 0, as long as one of the factors is 0, you know that the whole thing is going to be 0, right? So maybe you didn't understand what I'm saying about that, but if I do this problem, maybe it'll help you. So I'm just going to demonstrate the problem. You watch and see if you understand, okay? So first thing I'm going to do is I'm going to try to move everything to the left side so that on the right side I end up with equals 0. So first thing I'm going to do is I'm going to subtract x from both sides, and I'm going to get x squared plus 2x minus 5 equals negative 2. Now I have a negative 2 on this side. I want to get rid of that. So I add 2 to both sides. And I'm going to get x squared plus 2x minus 3. And the right side, of course, is going to be 0. Now I have x squared plus 2x minus 3. Okay, now I just need to figure out what x value makes that 0. Okay, there's a couple ways to do that. One of the ways is to use the calculator, okay? But just to show you how you would do the whole thing with algebra, I'm going to show you how to do it with factoring or with quadratic formula, okay? So if you look at this, it's 1x squared plus 2x minus 3. The values of x which make this 0 are x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And we could put in the a value of 1, the b value of 2, and the c value of negative 3 in this formula, and we would get two possible answers. The other way you could do it is you could do it by factoring, okay? So I'm not going to go through factoring here. Most of you are done with factoring. But basically, the two factors of 3 are 1 and 3, and we just need to figure out that this one is going to be plus and the other one's going to be minus, and let's check to make sure that works. 3 times negative 1 is negative 3. X times x is x squared. And negative 1x plus 3x is indeed 2x. So that is equal to 0. And x equals 1 and x equals negative 3 are the values that make that 0, right? Because if I say, okay, for this to be 0, this has to be 0, or this has to be 0, right? So when is x minus 1 equal to 0? It's equal to 0 when x equals 1. When is x plus 3 equal to 0? X plus 3 equals 0 is 0 when x equals negative 3. Okay? Easy, right? Now, oh, interesting. 1 and negative 3. 1 and negative 3. Okay, so the x values that came out of the calculator in the intersection function are the x values that come out of the algebra solution too. Okay, now if we wanted to find the y values that correspond to that, we would put 1 and negative 3 back into this equation or this equation, either one, okay? Of course, this equation is much easier, right? So if I put 1 into that equation, it would give me 1 minus 2, which is negative 1. If I put negative 3 in that equation, negative 3 minus 2 is negative 5. So, but like if you put it into the quadratic equation here, it would give you the exact same result because those 2 points are common to both functions, right? Okay, so it said to solve for x, we did. Do you get the same answers as you did for part A? Yes, we did. Part C, the function h of x equals 2x minus 3 has the same domain. Find the points of intersection between f of x and h of x. So now we're going to find the points of intersection between that parabola and this line. So the only thing different you would do is, for instead of y2 being x equals 2, the y2 would be 2x minus 3, and you would go ahead and do second calc intersect also, okay? So I'm going to go through the algebra, okay, of doing that. And if you would like to, while I'm doing the algebra, you can go ahead and find the calculator solution, see if you can do it faster than I can do the algebra. I bet you probably going to beat me by a mile. Okay, so x squared plus 3x minus 5 is the function f of x. And that is equal to h of x, right? And h of x is 2x minus 3. You should have already put these into y1 and y2. Now I'm going to move everything to the left side and leave 0 on the right side. So I'm going to subtract 2x from both sides. I'm going to add 3 to both sides. And the left side is going to be x squared plus 1x minus 2. And the right side is going to be 0. And x squared plus 1x minus 2. Is that right? Okay. And then I'm going to factor it. X minus 2, x minus 1. So I think that this one should be positive. So negative 1 times 2 is negative 2. Negative 1 times negative 2 is negative 2. Negative 1 times 2 is negative 2. X times x is x squared, and negative 1x plus 2x is equal to 1x. So everything worked out. So that is correct factoring. And then I say, okay, when does x minus 1 equal to 0? Well, when x equals 1, of course. When does x plus 2 equal 0? Well, when x equals negative 2, of course. So those are the two possible answers from an algebra approach. And if I wanted to figure out what the y coordinates are that correspond to each of these, I would plug them back into the 2x minus 3 equation, because that is a much easier substitution. So I could put 1 into 2x minus 3, I would get 2 minus 3, which is negative 1. I could put negative 2 into 2x minus 3, which would be negative 4 minus 3, negative 7. Okay, so this would be one of the coordinates, and this would be the other pair of coordinates. And now, I went through that really quick because in math studies you do not need to know how to do that. But some of you might be curious. And now what I'm going to do is I'm going to go into y equals, and I am going to solve for the intersection of these. So I input the parabola into y1, the line into y2, and I'm going to graph it. And doing the intersection of two functions only is a lot easier because you don't need to specify which functions you're going to intersect. The calculator already kind of knows, okay? It's still going to ask you anyway. So now we are going to go ahead and do second calc intersect to find these 2 points of intersection. So second calc, oops, didn't mean to do that. Second calc intersect, which is option 5. First curve, yeah. Second curve, yeah. Since there's only 2 curves in y1 and y2, it's of course going to be correct. We move the cursor closer to the point, the left point, and we hit enter. And it's going to be negative 2 comma negative 7. So one of the points is negative 2 comma negative 7. Hey, what do you know? Look, negative 2, negative 7. The other point is going to be, we're going to move the cursor now with the right arrow closer to the right side. Now we hit enter, and another point is 1 comma negative 1. Hey, look, 1, 1, just like before. So we're fine. Graphically, or with the calculator, we were able to solve for the exact same pair of points of intersection. Now, the other thing is, it says it has the same domain. Let's just make sure that the domain includes both of these. So the domain was -5 to 2. Are my x-coordinates here between -5 and 2? Yes, they are. Now remember, domain is the x-coordinate, not the y-coordinate. So we just need to make sure that 1 and -2 are both between -5 and -2, and they are. So that the domain part of it checks out also. Okay. All right, let's go to the next one. Number 2. Find the coordinates of the points of intersection of the graph x squared plus 3x minus 5 for the domain -5 to 2. Remember, x is an element of real numbers, just means that no imaginary numbers, but in math studies we don't use imaginary numbers anyway, so we're fine. They're just the numbers that you know and love. And the line x plus y plus 5. Okay, so first thing we're going to do is we're going to type it in the calculator, and then we're going to discover there might be a problem. So we have x squared plus 3x minus 5. And then we're going to put the line there, but look, the line is not ready to put in there because do you see how the calculator wants y equals on the left side and everything else on the right side? Look at this equation. This equation does not have y by itself on the left side. So it is not ready to put in the calculator. So, okay, remember when I said that you don't have to do algebra in math studies? Well, you have to do a little bit. Okay, so when you get x plus y plus 5, our objective is to change this so that only y is on the left side and nothing else is there. So what we're going to do is we're going to subtract x from both sides so that we end up with y plus 5 equals -x. Then we're going to subtract 5 from both sides, and then we're going to get y equals -x minus 5. Once we do that, it is ready to put in the calculator into y2, right? So into y2, I'm going to put -x minus 5. Do you know the difference between this button and this button? If you put this button, you're going to be fine because -x, oops, I didn't mean to do that. Sorry about that. It goes to y2. So y2, we're going to put -x minus 5. If you put -x minus 5, if you use the minus sign for this leading negative here, the calculator is going to have a problem because the calculator thinks that this is actually quite different than this. So if you have a leading negative or minus sign, you need to put this here. When I say leading, I mean the first position. If you have a negative, you need to put a negative sign and not a minus, okay? So now we're going to do the same thing where we're going to find the intersection of these of the curve and the line, and we're going to do second calc. Now this part, go ahead and pause this and do it on your own because you already know how to do this, and see if you can get the answer without watching me do it. So here it's going to ask us first curve and second curve, and of course it's going to know which curve it is because we only have 2 curves in the calculator. Be careful if you have a whole bunch of old curves in the calculator. You need to be careful about make sure that this is the right one, make sure that the other suggestion it makes is also the correct one. Okay, now for the guess. Remember that the guess should be close to the one you want. So if I want to know the left one first, I'm going to put the cursor close to the left one. It tells me that the intersection is -4, -1. A lot of times you guys have trouble seeing the negatives since they're very close to the equal sign, and sometimes you neglect to write the negative. So be careful about that too. The other point would be this one down here. Let's find that one. Also doing second calc intersect, and we just repeat the whole procedure again. By the time you do one worksheet, you are experts in doing this procedure because you're going to do it like, 10 times. And then, you're like, I don't need to do it 10 times. I'm like, really good at remembering things. Okay, maybe you can remember things till next week, but I guarantee you, if you do not do this repeatedly, you will not remember in December, and you will not remember in May of 2020. Calculator display brings up a very good point. There is one tricky thing about interpreting answers from the calculator. When you look at this, it has -1.15 e -15. What does that mean? That actually means -1.15 times 10 to the -15th. Do you remember what 10 to the -15th or 10 to the negative huge number means? It basically means 0.00000001 something something. So it's like a really small number. Basically, when the calculator says that, it means 0, okay? So we know that the x-coordinate here that they're giving us is 0, and the y-coordinate is -5, okay? So on the exam, interpret that as 0. All right. Going to the last problem. Find the points of intersections of the graphs of, and it gives us two functions here, f and g, and these are quite easy. We just put them in the calculator under y equals x squared. It's in a little bit different order than usual. Usually I have x squared first. In this case, they start with the number 5 plus 3x minus x squared. And the bottom one is going to be y equals 1. And then we're going to graph them. And then we're going to find the intersections. And the way we find the intersections is we do second calc intersect. And the first curve, second curve, we just hit enter, enter. And the guess, for the first guess, we'll go to the left side. The intersection is -1, 1. -1, 1. What's the second intersection? We have to repeat. Second calc intersect. First curve, second curve, guess. We put the guess too close to the left side. We got the same answer again. We don't want that. Second calc intersect. Enter, enter, and now our guess is going to be closer to the right one. Enter. Intersection 4, 1. Okay. Now the next one has the same f function and a different h function. Okay, so let's find that. So we're going to put, yep, there's the trash tomorrow. Okay, 5 plus 3x minus x squared, 2x plus 3. That's actually Brad. He's reminding himself that he needs to take out the trash tomorrow. 2x plus 3. Okay, so we're going to do the graph, and we are going to find the intersection between this parabola and this line. Oh, it intersects in two places. So we're going to do second calc intersect again. Now you're getting to the point where it's like, okay, I can do this. So why are you still watching me? Turn this off. Do it yourself, okay? If you think it's so easy, just do it yourself. Just come back to check the answer if you want. So the first intersection point is -1, 1. -1, 1 again? That was the answer on the first one. Now let's find that one. Second calc intersect. First curve, second curve. Now I need to move the guess closer to the second one because I want the second one. Intersect 2, 7. All right. There we go. We're done with this page.